I present a scenario that would make any normal person's mouth go dry. We've just closed the file on the comet that burned up in the sun's atmosphere. We breathed a collective sigh of relief, calling it a beautiful but harmless firework. But today, we're going to do what is forbidden in the news but allowed in science. We're going to run a thought experiment. We'll change just one variable in the orbital equation. Imagine the comet's angle of entry into the plane of the ecliptic was different. Imagine a gravitational assist near Jupiter shifted its trajectory by only 1/100th of a degree, and now, this ice mountain accelerated to insane velocities is not heading for the sun, it's heading for us. Welcome to the Doomsday Simulation. Today, we won't discuss the beauty of the tail or the chemical composition of the coma. Today, we will discuss TNT equivalents, shockwaves, and zones of total destruction. The internet loves these headlines. Where will the debris land? The map of death. Will your city survive? Usually this is pure clickbait, engineered to sell ads. But space is a shooting gallery, and the targets move. Earth is a target 12,000 kilometers across, and while the probability of a hit is negligible, it's never zero. The history of our planet is written in craters, and today, we'll write another hypothetical chapter in that history. Let's look at our aggressor, Comet C2024 S1 Atlas. In reality, it was a loose chunk of ice and dust. But for our scenario, we will assume the nucleus was dense enough to punch through the atmosphere. Let's say its diameter was about a kilometer. By cosmic standards, a speck of sand. By human standards, a mountain flying at a speed that turns any material into plasma upon impact. The comet's speed on a collision course with Earth can reach 70 kilometers per second. That's hundreds of times faster than a bullet. This is the velocity where the physics of solid matter ends and the physics of explosion begins. The first thing humanity will feel in this scenario isn't the impact, it's the paralyzing, sticky terror of waiting. Unlike asteroids, which often sneak up on us from the sun's direction, we see a comet coming from afar. For several months before the 0 hour, it will become the brightest object in the sky. It will hang overhead like the sword of Damocles, growing larger every night. Social media will turn into hell. The economy will collapse because no one will go to work knowing everything ends in a week. Religious cults will take to the streets. This will be a time of total psychological breakdown. We will know the date and time with second-by-second precision, but we won't know the main thing. Where exactly? The problem with predicting the impact point is that the Earth rotates. An error in the arrival time of just 1 minute shifts the point of impact by thousands of kilometers in longitude. While the comet is distant, the target zone is the entire planet. It's planetary Russian roulette. London, Tokyo, the Pacific Ocean, or your backyard. Astronomers will refine the trajectory every hour, narrowing the corridor of death, and the entire world will watch this like a lottery, where the grand prize is life and the loss is vaporization. Let's revisit history to understand the scale. 66 million years ago, the Chicxulub asteroid, about 10 kilometers in diameter, slammed into the Yucatan Peninsula. The result? The extinction of the dinosaurs, a nuclear winter, and acid rain. Our hypothetical guest is smaller, just 1 kilometer. Does that mean we get off easy? No. Kinetic energy depends on the square of the velocity. Comets typically fly faster than asteroids. The impact of a 1 kilometer body at 70 kilometers per second will release energy equivalent to the detonation of tens of thousands of hydrogen bombs exploding at a single point simultaneously. This isn't the end of the world in the biblical sense, where all life perishes. This is what military strategists call unacceptable damage. If such a mass falls into the ocean, it will generate a tsunami hundreds of meters high, washing away continental coastlines and destroying the world's largest cities. New York, Shanghai, Rio de Janeiro. If it hits land, it will carve out a crater the size of Paris and lift so much dust into the stratosphere that the sun will dim for several years, causing global famine and the collapse of agriculture. Why is it so important for us to run this scenario? Not to scare you before bed, but to understand the fragility of our civilization. We've built a glass house at a cosmic crossroads. We've grown accustomed to thinking we are the masters of the planet. But one rock flying out of the Oort cloud can prove to us that we are just renters here who can be evicted without notice. We often hear comforting phrases from NASA. There is no threat for the next 100 years. But the word probability is a tricky thing. The probability of you winning the lottery is also negligible, yet someone wins every week. In the cosmic lottery, the jackpot was the Tunguska event. In 1908, we got lucky. It fell into the taiga, where there was no one but reindeer. But if it had arrived 4 hours later, due to the Earth's rotation, St. Petersburg would have been under the impact zone. The city would have been wiped off the map. The history of the 20th century would have taken a different path. In our investigation, we will go all the way. We won't rely on luck. We will take the parameters of Comet Atlas, load them into the ballistic simulator, and hit the start button. We will examine what happens in the first seconds of atmospheric entry. We will see how air turns into a solid wall from shock compression. We will analyze the physics of the shockwave that will circumnavigate the globe several times. And we will answer the question, do we stand any chance of shooting down or diverting such a threat if we only learn about it 6 months out? Or will all that be left for us is to watch the beautiful show of the final sunset? Get ready, it's about to get loud. We are beginning the countdown to a collision that, thankfully, did not happen in reality, but which is inevitable in the future. The only question is when. To grasp the scale of the threat hanging over our heads in this scenario, we must set aside emotions and open a physics textbook to the chapter on kinetic energy. Hollywood movies often show heroes detonating an asteroid with a nuclear missile seconds before impact, and it shatters into tiny pieces that burn up beautifully in the atmosphere. This is a lie. It's a dangerous lie that lulls us into complacency. In reality, we are dealing with the energy of motion, which cannot simply be canceled. The formula for kinetic energy is mass multiplied by the square of velocity and divided by 2. The key word here is the square of the velocity. Our hypothetical projectile, Comet Atlas, is not just fast, it is monstrously fast. Let's break down the parameters of our killer. The closing speed of the comet with Earth can reach 70 kilometers per second. To put that magnitude into perspective, a bullet fired from a sniper rifle travels at about 1 kilometer per second. The comet is 70 times faster. At such speeds, matter ceases to behave like a solid. It behaves like a fluid, like plasma, like pure radiation. If you were to throw a steel ball at a steel wall at that speed, they wouldn't collide. They would instantly transition to a gaseous state, exploding with a power that exceeds the power of chemical explosives of the same mass by tens of times. An asteroid or comet is not a rock, it is a kinetic bomb. The first barrier our guest will encounter is the atmosphere. The thin blue line that protects us from small cosmic debris will become not a shield, but a detonator for a kilometer-sized body. When an object invades the air at hypersonic speed, a phenomenon called gas compression occurs. The nitrogen and oxygen molecules in front of the comet simply do not have time to move aside. They are compressed into a dense cushion where the temperature instantly soars to tens of thousands of degrees. This is hotter than the surface of the sun. The air turns into plasma. The comet begins to burn not only on the outside but everywhere at once. And here we come to a fork in the road of scenarios, which depends on the composition of the nucleus. If the comet is porous, as we assumed in our real-world investigation, it won't reach the ground. It will explode in the air. This is called an airburst. This is exactly what happened on June 30th, 1908, over the Podkamennaya Tunguska River in Siberia. The Tunguska object was relatively small, perhaps 50 or 60 meters in diameter. It entered the atmosphere and, unable to withstand the pressure, exploded at an altitude of 5 to 10 kilometers. The result? 2,000 square kilometers of taiga were flattened like matchsticks. The trees lay in a fan from the epicenter. The blast wave circled the globe twice. The flash was visible hundreds of kilometers away, and seismic stations in Europe recorded an earthquake. Now, let's scale that up. Our hypothetical Comet Atlas has a diameter not of 50 meters, but of 1 kilometer. Volume and therefore mass grows cubed. This body is thousands of times more massive than the Tunguska meteoroid. If such a mountain explodes in the atmosphere, it won't just flatten a forest. It will annihilate a city the size of Moscow or New York, leaving behind molten glass. The shockwave will be so powerful that it will kill people hundreds of kilometers away, not with debris, but purely with the pressure differential, rupturing lungs and eardrums. Buildings will fold up like card houses even before the sound of the explosion reaches them. But let's consider the worst-case scenario. Assume the comet's nucleus was denser than we thought, or the entry angle was too steep. The comet pierces the atmosphere in a couple of seconds and hits the surface. This is where the geology of catastrophe comes into play. 70% of the Earth's surface is water. The probability of an ocean impact is 7 out of 10. What happens when a red-hot iron the size of a mountain falls into a bathtub? There will be steam. Lots of steam. The moment it hits the water, the comet won't stop. It will puncture the entire ocean depth, even if it's the Mariana Trench. The water in front of it instantly vaporizes, creating a cavitation void, an empty cylinder in the ocean that momentarily exposes the seabed. But water is incompressible. The shockwave will radiate in all directions at the speed of sound in water, 1.5 kilometers per second. This will generate a mega tsunami. These are not the waves we saw in Thailand or Japan. Those were caused by a meter or so of seafloor displacement. Here, we're talking about energy that displaces cubic kilometers of water. The first wave could reach a height of 1 kilometer. Imagine a wall of water as tall as the Burj Khalifa skyscraper, speeding toward the coast at the velocity of a jetliner. When it reaches the shelf, it will slow down but grow even taller. This tsunami will wipe out Florida, Portugal, and all of Japan. It will penetrate hundreds of kilometers inland, turning coastal plains into the seafloor. But the most terrifying factor is water vapor. Millions of tons of superheated steam will be ejected into the atmosphere. Steam is a greenhouse gas, far more potent than carbon dioxide. This will lead to an immediate catastrophic climate shift. First, monstrous hurricanes fueled by ocean heat, so-called hypercanes capable of stripping bark off trees. Then, rains that will last for months, flooding what the tsunami didn't wash away. And what if we are lucky and the comet hits land? Say, the Sahara Desert or the Siberian taiga. At the moment of contact, kinetic energy converts to thermal energy. An explosion will occur, equivalent in power to the simultaneous detonation of the entire nuclear arsenal of humanity, multiplied by 10. A crater will form. For a 1-kilometer body, the crater diameter will be about 20 kilometers. The depth, several kilometers. In the center of the crater, due to the rebound effect, a central peak will rise, a spike composed of mantle rock that bounced upward like a drop of milk. But the crater is just the scar. The killer will be what flies out of it. The ejecta, billions of tons of rock, melted and turned into dust, will be thrown into the stratosphere and even into space. Part of this debris will fall back to Earth within hours, incandescent upon atmospheric re-entry. The sky across the entire planet will turn red, like an electric stovetop coil. The air temperature will climb to 200 degrees. Forests will ignite simultaneously on all continents. This will be a global firestorm. The dust and soot from the fires will block the sun. Asteroid winter will descend. Photosynthesis will halt. Plants will die. They will be followed by herbivores, then carnivores. Food chains will collapse. This exact scenario put an end to the dinosaurs 66 million years ago. The impact in the Yucatan Peninsula, the Chicxulub crater, that asteroid was larger, 10 kilometers. But even our 1-kilometer little guy is enough to send civilization back to the Stone Age. Electronics will fail, agriculture will become impossible, cities will turn into death traps. Those who survive will be the ones who can grow mushrooms in basements and filter radioactive water. Let's draw a historical analogy to understand our vulnerability. In 2013, a bolide only about 20 meters in diameter exploded over Chelyabinsk. 20 meters, the size of a house. It exploded at an altitude of 20 kilometers. The shockwave blew out windows across the entire city, injuring 1,500 people and collapsing the roof of a zinc factory. That was a grain of sand. Our comet is 50 times larger in diameter and 125,000 times heavier in mass. The energy of Chelyabinsk was 500 kilotons. The energy of Atlas is 50,000 megatons. Comparing them is like comparing a firecracker and the eruption of the Krakatoa volcano. The mechanics of destruction also include a seismic strike. The fall of a 1-kilometer body will cause an earthquake with a magnitude above 10. Humanity has never recorded such quakes in history. The Earth's crust will move in waves like a shaken sheet. Faults will open where they never existed. Dormant volcanoes will awaken. If the impact occurs in a volcanically active zone such as Yellowstone, it could trigger a supervolcanic eruption that will finish off what remains of the biosphere. In this grim scenario, there is one important nuance: the comet's composition. We remember that Atlas is a dirty snowball. Unlike iron asteroids, a comet carries a huge amount of volatile substances: cyanides, carbon monoxide, ammonia. Upon vaporization, they will locally poison the atmosphere at the impact site. This will be a chemical attack of cosmic scale. The rains that follow the impact will be acid rain. They will burn the leaves off trees and poison freshwater reservoirs. The ocean will begin to acidify, killing plankton and corals. Thus, the dossier of our mechanical killer looks as follows. Weapon: a kinetic warhead weighing billions of tons. Speed: hypersonic. Method of killing: combined. Shockwave, tsunami, thermal radiation, global firestorm, nuclear winter, acid rain. Humanity has no shield against such a weapon. Our missile defense systems are designed to shoot down thin, slow missiles. They are useless against a mountain flying from the zenith. But the most terrifying thing in this investigation is not the description of the destruction. The most terrifying thing is the silence. Space is a vacuum. The comet's approach will be soundless. We will see it, but not hear it. The sound will only come after the impact. And for those who find themselves in the direct impact zone, there will be no sound at all. The nervous system will not have time to transmit a pain signal to the brain. They will simply disappear, becoming part of the plasma. In the next part of our hypothetical scenario, we will try to find hope. We will simulate the actions of governments and scientists in the 6 months we have before impact. Can we build arcs? Can we send a Bruce Willis mission? Or will the only way out be acceptance of the inevitable? We will dissect the social mechanics of the end of the world. How will people behave knowing the date of their death? Chaos or solidarity? Looting or prayer? This will be a test not of concrete strength, but of the strength of the human spirit. We are entering the most intense phase of our simulation. The orbital parameters are confirmed. The impact point is determined. Let's assume it's the center of the Atlantic Ocean. Time to contact: 6 months. This is the exact time frame that separates ordinary life with morning coffee and traffic from the moment the ocean boils. In this chapter, we will examine not the physics of the rock, but the physics of human despair and technological impotence. We will conduct a crash test of our civilization. Can we unite in the face of annihilation, or will we destroy ourselves even before the comet touches the atmosphere? This is the culmination of the history of the species Homo sapiens. The world's first reaction is not panic, but bureaucratic paralysis. The governments of nuclear powers, the US, China, Russia, convene emergency security councils. Folders with planetary defense plans lie on the tables. But the problem is that these plans exist only in theory. We have never, I emphasize, never tried to divert an object of this size at this speed. The DART mission conducted by NASA in 2022 successfully nudged a tiny asteroid moon. But Comet Atlas is thousands of times heavier. It's like trying to stop a freight train by shooting it with a pellet gun. Nevertheless, a decision is made. Operation Last Chance. The whole world watches the launch of interceptors. We cannot use a gravitational tug. We don't have the time. Such missions require decades. We cannot use a kinetic impact. The comet's mass is too great. Only one means remains that we saved for fighting each other: nuclear weapons. The idea is simple. Detonate a series of megaton warheads near the surface of the nucleus to vaporize some material. The reactive thrust from the vaporization should nudge the comet off course, and this is where the enemy's cunning comes into play. A comet is not a monolith. We remember the lessons of comets Y4 in S1. It is a dirty snowball riddled with cracks. The shockwave from a nuclear explosion does not push the entire nucleus. It passes through it like ultrasound. Instead of being diverted, the comet shatters. We turn one bullet into a shotgun blast. Instead of one crater that would destroy Europe, we get a meteor shower that blankets the entire northern hemisphere. Radioactive cometary debris. The simulation shows a late-stage interception attempt increases the impact area many times over. We lose the battle in space. The second act of this drama unfolds on Earth. The social contract that holds our society together is nullified. Why pay the mortgage if the bank won't exist in 6 months? Why go to work if the result of your labor will burn? The economy stops instantly. Stock exchanges close forever. Money loses all meaning. The only currency becomes canned goods, water, medicine, and ammunition. Cities descend into chaos. Police and the military desert to be with their families. The Great Migration begins. If the calculated impact point is the Atlantic, billions of people from Europe, America, and Africa try to reach safe zones deep into Siberia, Central Asia, the mountains of Tibet. Roads turn into car cemeteries. Crowds storm airports. Governments declare martial law, but no one obeys the orders. We see how fragile the veneer of civilization is. In the face of death, we become tribes again, fighting for a cave. And what about the chosen ones? The construction of arcs, but not cosmic ones. Flying to Mars in 6 months is impossible. The focus is on underground cities. Deep bunkers from the Cold War era are recommissioned. In the mountains of Norway, the rock masses of Colorado, and the mines of the Urals, work is frantic. But there is only enough space for a fraction of a percent of the population. Who makes the list? Politicians, scientists, or those who win the lottery? This moral choice tears apart the remnants of society. Rumors of golden tickets provoke riots. People try to storm the bunkers, and guards open fire. It's a war of all against the backdrop of a burning sky. Meanwhile, a mesmerizing and terrifying show unfolds in the sky. The comet approaches. 3 months before impact, it is visible to the naked eye as a dim star. A month out, it is brighter than Jupiter. A week out, it is visible during the day. It hangs at the zenith like a second eye, malicious and unblinking. Its tail spans half the sky, creating eerie blood-red sunsets due to light scattering in the dust. Nights become bright. The human psyche breaks down. Psychiatric clinics are overcrowded and then close entirely. Religious sects gather in city squares, singing hymns to welcome the purification. Doomsday arrives. The final 24 hours. The comet enters the Earth's sphere of influence. It is no longer flying. It is falling. Its apparent size increases every minute. It's no longer a dot. It's a disk on which details of the terrain can be discerned. Mountains and canyons of an icy hell. The comet's gravitational influence begins to be felt on Earth even before impact. Tides go wild. Water retreats kilometers from the shores, exposing the seabed, as if the ocean is taking a deep breath before a jump. Animals howl. Birds fall from the sky, disoriented by magnetic storms. The simulation shows the moment of atmospheric entry. It happens silently for the observer on the ground because the object is flying faster than sound. People see a flash. It is brighter than 1,000 suns. Those who look directly at the comet are instantly blinded. Retinas are burned out. The sky rips open. It looks as if someone drew a giant lightning bolt across the celestial vault, revealing a dazzling white abyss behind it. The air in front of the comet is compressed into a plasma state, glowing purple and blue. Seconds after the flash, the thermal wave arrives. It's not wind, it's heat. Forests, clothing, hair, and paint on cars spontaneously ignite within a radius of thousands of kilometers from the epicenter. Cities turn into ovens. Asphalt melts and runs in rivers, and only then does the sound come. The shockwave. It moves like a wall of compressed air, sweeping away skyscrapers like dust. But let's return to our impact point, the Atlantic Ocean. The comet pierces the atmosphere in 2 seconds and crashes into the water. At this moment, time for humanity is divided into before and after. The impact energy vaporizes cubic kilometers of water. The ocean floor fractures, exposing the mantle. A plume of steam and molten rock rises into space, forming a mushroom cloud hundreds of kilometers high. This cloud is visible from the moon as a black ulcer spreading across the blue face of the Earth. The twist in our scenario is that the worst happens not at the moment of impact, but in the first hours afterward. We feared fire, but the killer will be darkness. The ejecta, the displaced rock, enters a suborbital trajectory and begins to fall back across the entire planet. Billions of meteors. The sky becomes a red-hot oven lid. Global atmospheric temperature rises to hundreds of degrees. Those who were not immediately burned are baked alive. The only chance to survive is to be deep underground. At this point, our simulation stops. The screen goes dark. We catch our breath. This was just a scenario. Comet Atlas burned up in the sun. It did not hit the Earth. But this thought experiment revealed one important detail that we rarely talk about. The main vulnerability of our civilization is not the lack of missiles, but the lack of unity. In our model, we perished not because we couldn't shoot down the comet, but because we spent the last months in panic, selfishness, and dividing up the bunkers. Technically, humanity has the potential for defense. If we had detected the threat 5 or 10 years ago, we would have managed. We could have used a gravitational tug or an ion engine to slowly, delicately change the orbit. But this requires a global monitoring system hundreds of times more powerful than the current Atlas. And it requires the political will to spend trillions of dollars not on aircraft carriers, but on telescopes and space interceptors. This scenario is a vaccination against complacency. We live in a cosmic shooting gallery, and the fact that we are still alive is statistical luck that cannot last forever. Tunguska was a warning. Chelyabinsk was a reminder. Comet Atlas was a demonstration of nature's power. The question is not whether something will fall again. The question is whether we will be ready to meet that impact, not as fragmented tribes, but as a planetary civilization. In the final part, we will exit the simulation bunker onto the surface of the post-apocalyptic world. We will see what remains of the Earth 1 year after the impact. Is there life in the asteroid winter? And can the comet's fall become the beginning of a new cycle of evolution, as happened after the demise of the dinosaurs? We will find hope where, it seemed, only ashes remained. We turn off the simulator, the screens go dark, and the terrifying graphs of shockwaves and temperature spikes disappear. We take a breath. In this moment, when you realize the scale of what happened in the quiet of the office, even hypothetically, it becomes clear why humanity is so afraid of the starry sky. Comet Atlas did not fall, but the scenario of its impact revealed the most terrible secret. Our civilization is indecently fragile, and our technological progress, which seemed unbreakable, can be wiped off the face of the Earth by a single chunk of ice. In this concluding chapter, we will exit the simulation bunker and look at the world 1 year after the 0 hour. We will assess the consequences and find what remains of the human spirit. First, the physical picture. 1 year has passed. The planet survived not just an impact, it survived a combined attack. We are dealing with a post-apocalyptic world plunged into an asteroid winter. The sky, obscured by billions of tons of dust and soot from global fires, has a dark orange or brown hue. The sun is a dim, invisible disk. The average temperature on the surface has dropped by 10, and in some places by 20 degrees. Eternal autumn turning into an icy winter. That is the climate for the next 3 to 5 years. Photosynthesis has practically ceased. Plankton, the foundation of the entire marine food chain, has died in the ocean. On land, major forests have perished, covered with a layer of acid rain and soot. The former continents, North and South America, Europe, Asia, lie under a thin but deadly layer of cometary and terrestrial ejecta. The areas closer to the Atlantic, where the comet fell, underwent total sterilization. The shockwave and mega tsunami wiped coastal megacities down to the bedrock. We lost 90% of major cities, ports, and industrial infrastructure. Electricity, communications, the internet all ceased to exist in the first hours. We have returned to the age of steam and muscle power. Now, the human population. According to the simulation estimates, if there were no system of bunkers, no more than 1% of the population would have survived. Out of 8 billion people, fewer than 100 million would remain. These people are unevenly distributed. The majority perished from the shockwave, thermal radiation, and tsunami. Those who survived are dying now from hunger, cold, disease, and radiation contamination. The largest pockets of survival are deep underground, in mines, abandoned military bases, in the mountain gorges of Central Asia, or deep in Africa, where the wave or tide did not reach. These survivors are not the lucky holders of golden tickets. They are people who won the right to live in hell. The social landscape has changed irrevocably. Former states have vanished. Only local, armed, and desperate groups remain, fighting for the last supplies of food. The only form of organization is what remains of military bases that manage to maintain communication and generators. Scientists and engineers who survived in bunkers become the most valuable currency. Their task is not to revive civilization, but simply to sustain life. They must learn to grow food in the conditions of an asteroid winter, filter contaminated water, and defend themselves against marauding gangs who failed to get into the bunkers. But in this doomsday scenario, there is a turning point that offers hope. The comet's fall, by destroying the former civilization, removed all its chronic diseases from the Earth. Borders disappeared, national disputes disappeared, currency wars disappeared. Only one global, absolutely clear goal remained: to survive. Those who survived will be forced to unite. Survival will depend on solidarity, on the exchange of knowledge and resources. For the first time in human history, people will not face the choice of whom to serve, a president or a king. They will face the choice of how to rebuild a fire in the darkness. This leads us to the main philosophical conclusion of our investigation. Comet Atlas, even without falling, taught us the most important lesson about the relativity of our problems. We spend trillions of dollars on an arms race and advertising, arguing about politics and national borders. And on a cosmic scale, all these disputes are meaningless noise. In the face of 50,000 megatons of kinetic energy, it doesn't matter what your passport is or how many stocks you own. We all become equally vulnerable. This hypothetical scenario is not a curse. It is a calibration tool. It allows us to understand that our true nationality is terrestrial, our true border is the atmosphere, and our only common project is an early warning system. The impact scenario showed our technological impotence at the late stage. A nuclear explosion that fragments the comet is a direct result of our political and financial impotence at the early stage. If we spent not fractions of a percent, but at least 1% of the global GDP on space monitoring, the threat could have been detected decades ago and resolved with an elegant, slow gravitational tug. In the final analysis, Comet Atlas, which we shot down in our simulation, leaves us two legacies. The first is a physical legacy, a crater in the ocean, a new climate, and a new geological epoch. The second is a mental legacy, the realization that we must spend resources on defending our atmosphere, not on fighting each other. Life on Earth will resume, as it did after Chicxulub. After all, after the extinction of the dinosaurs, man appeared. And after this event, perhaps a new, more resilient and unified species will emerge. As a final address, we exit the simulation into the real world, where Comet Atlas burned up in the sun, and Nibiru is just a myth. But the Tunguska meteoroid, the Chelyabinsk meteor, and the asteroid Apophis are real. They are flying. They are waiting. The question that should hang over every board of directors, every parliament, every head of state is this: will we wait until statistical luck runs out, or will we start building our planetary defense today? Will we invest in telescopes that save all of us, or in bunkers that save one of us? This scenario is not about the end of the world. It is about the beginning of a new era in which humanity must grow up, an era in which we recognize that our civilization is one crew on one ship, and if a hole appears in the hull, the whole crew sinks. Don't let fears and clickbait distract you from the main thing. Look up at the sky and demand that those who govern the world look there with you. Until the next broadcast on the Frequency of Science.